On Friday, we talked about how when two parallel lines are cut by a transversal, I had all these different angle pair properties that existed. We saw how the corresponding angles were congruent, the alternate interior angles were congruent, alternate exterior angles are congruent, and that the same side interior angles were supplementary. The converse of all of those statements, the converses, rather, of all of those statements are also true, and you see them on the screen. So if I have two lines cut by a transversal, and I happen to notice one of those angle properties, I can use that angle pair relationship to prove that lines are parallel. Okay, so if two lines are cut by a transversal such that the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent, or the same side interior angles are supplementary, then I can use that to conclude that the two lines are parallel. Remember the symbolic notation for parallel lines. A couple of things. Notice the names of these properties all include the word converse. On a test or quiz, I told you all last week, if you wrote down postulate instead of theorem or vice versa, I would not ding you for that. That's not a big concern for me. If you write down converse and what you were actually using was the original property, do you suspect that you would get dinged for that? Yes, because now you're talking about two completely different properties, and you need to make sure that you know which one is used for what. Okay, so somewhere you might want to stress in your notes that the converses, these converses, are used to show that lines are parallel. Whereas the properties from Friday are used to say something about angles. These properties, I know something about the angles, and I'm using that to draw a conclusion about lines. In problem 1, we're being asked which lines are parallel if angle 2 is congruent to angle 3. The strategy that you're employing in order to kind of answer that question is first, again, to figure out what kind of angles they are. So angles 2 and 3, hopefully by now we're fluent enough in these angles, everybody can tell me what kind of angles 2 and 3 are. What kind of angles are they? Yes, Sarah. They're alternate interior angles. And then here's my next question to you. They're alternate interior angles with respect to what two lines? Because those are the two lines that are going to be parallel. We're hearing a split. I hear some of you saying A and B. I hear some of you saying M and N. Trent, what do you think? It is N and M. And if you're struggling with figuring out which lines you're looking at, trace the lines that are forming the two angles. Okay, so my two angles are 2 and 3. So angle 2 is formed by this line, and angle 3 is formed by this line. Notice that line B has nothing to do with angles 2 and 3. Okay, so certainly line B isn't affected by angles 2 and 3 being congruent. So my answer is M is parallel to N because of the alternate interior angle converse. Also, let me backtrack. I neglected to address that description of learning, which I'm trying to be thorough about. Remember, you don't want to be at level 2. You want to, at the very least, be starting at level 2. It's Monday for me, too. You don't want to be at level 1. You want to, at the very least, start at level 2, where you're knowing the properties that are necessary in order to be able to do the things that get us to level 3. These properties are what get us to that level 2. Level 3 is being able to make these statements as we just did, identifying which lines are parallel, and then being able to complete a proof with them. In problem 3, in the interest of time, I'm going to hold off on your turn. This is problem 2. Oh, I put, you know what? It's at the very end because it's proof. I have it right here. We'll get there. Oh my goodness, that looks strange. In problem 3, I have that angle 1 is 65 and that angle 2 is 115, and they're asking us if lines A and B are parallel based upon that information. You tell me. If angle, 1 is 65 and 2 is 115, are the lines parallel? Yes. Why? Okay, and what kind of angles are they? Trent? Okay, so the answer is yes, and my explanation is what property? Yes.
Same side interior angle quadrant.
Beautiful, yes. Problem 4 is asking us for the value of x for which A is parallel to B. The wording is phrased a little bit differently than the problems from Friday's homework, but the process is still the same. The process is still identify what kind of angles they are, figure out what property must exist between them. In other words, are they going to be congruent? Are they going to be supplementary? Because those are our only 2 choices. And then set up your equation and solve from there. So, one person please. What would be my equation in order to solve for x in problem 4? Helena.
3x plus 3 plus 48 equals 180.
Fantastic. Yes. What did you observe about those angles to make you draw that conclusion?
They're same side interior.
Wonderful. Yes. 3x plus 3 plus 48 equals 180. And as I've said before, this, for some of you, tends to be the challenging part. Solving this, you can do with half your brain behind your back. So 3x plus 51. 3x is 129. So x is 43. Always go back and look at the question. Make sure you didn't miss some nuance. What is the value of x? No, we're good. We're good?
Oh, just kidding.
Wait. You don't have to tell if they're parallel. Read the question.
The question is asking us to find the value of x for which A would be parallel to B. Remember the property of these 2 angles. If these 2 angles are supplementary, then that would make the lines parallel. So we set up the equation so that those angles would be supplementary.
How are they supplementary? They don't equal 180.
We just set it up so that they... I'm not sure I've answered your question.
Because I thought like one's... Oh, okay.
Monday for you too? It happens.
It's always Monday.
All right, now the fun part. And you'll notice I've got some of the setup already indicated for you. And some of you are looking at this and saying, whoa, that does not look like any kind of proof that we have done in here. And you're absolutely right. It's called a flow proof. I may have mentioned that we were going to be doing it. Now we're doing it. One of the really nice things about a flowchart proof, and while I'm talking, you probably want to copy that basic setup of the proof. You'll notice it's not complete. One of the great things about flowchart proofs is the fact that those arrows really help clarify where statements are coming from. And I know it looks strange right out of the gate. Just take a moment, copy the steps down. We'll, of course, go through it together. And this is the last thing I'm doing in my lesson today, so credit is down for maintenance. So there's no daily quiz. All right, so one thing that the flowchart proof and the two-column proof that we're accustomed to have in common is that you're still making statements and you still have to justify those statements. So understand that in this flowchart layout, the statements are what's in boxes and the lines underneath them are indicating the reason for it. So the first statement that we see up here is that angle 5 is 40 degrees and angle 2 is 140 degrees. Why do I know that? Because it's given, yes. And then maybe the next thing you see is this box with the congruent supplements theorem, but you need to realize because of the arrow coming from this empty box going there, we're not ready to make that statement yet. We need to make this statement down here first. Well, what's that statement going to be? Conveniently, we have a hint. They're telling us that we're going to be using the linear pair postulate. Let me refresh your memory on what the linear pair postulate says. The linear pair postulate says if I have two angles forming a linear pair, I know that they're supplementary. So in this diagram, what linear pair do you observe? Alyssa. Angles 2 and 5 are same-side interior angles. Hold that thought. That's actually the property that we're proving.
Angle 1 and 5?
No, not 1 and 5. Casey.
5 and 4.
Angles 5 and 4, yes. So I can say that angle 5 and angle 4 are supplementary. And conveniently, we have used the congruent supplements theorem a couple of times recently, or we talked about it anyway recently. You'll recall it was one of the reasons in problems in our proof from Friday night's homework. So looking at these two statements, I don't see the word supplementary in this first box, but looking at those angle measures, do you observe that these two angles are in fact supplementary? Okay, so in these two statements, I'm going to put them together in order to say that two angles are congruent because they are supplementary to the same angle. What two angles, therefore, coming from these two statements, are congruent, Sarah? Angle 2 is congruent to angle 4, yes. And then you see this next box, perhaps, but I would hope that you'd realize we're not ready for that statement yet. I need to say something about angle 1 being congruent to angle 2, or I need to justify why angle 1 is congruent to angle 2. Sarah?
Is it the vertical angle postulate?
Vertical angle theorem, yes. And look at those two statements that I'm intended to put together in order to come up with saying that angle 1 is congruent to angle 4. I'm saying that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 4, and then I'm saying that angle 1 is congruent to angle 4. Grace. That's the transitive property, yes. And now I've got angle 1 and angle 4 congruent, and I'm using that to show that line A is parallel to line B. Look at angles 1 and 4. Trent. Precisely. So what property am I using? Corresponding angles, converse. Big ticket item. You must use the word converse. It takes getting used to. Do we have from this screen what we need? Okay, there's the homework